Pictorial representation of statistical data, pie diagram. In this diagram, the values of items or components are represented by sectors of circle formed using radii. The sectors resemble the slices of a pie, a bakery product like cake. Hence, it is called a pie diagram. The terms used in pie diagram are sector and central angle. In figures, O is the central of circle. The line segments OA and OB are the radii. The angle AOB is the central angle, and the shaded region OAXB in the circle is the sector. Construction of pie diagram. In the construction of pie diagram, we use the fact that the total of all the values of items or that of components corresponds to 360 degrees. So, the first step in drawing pie diagram is to find the central angle for each item or component using the following formula. Central angle is equal to value of the component upon total value of all components multiplied by 360 degrees. The next step is to draw a circle of convenient radius. Divide the circle into number of sectors to represent the various items or components. Clearly, there is one sector for each component. Hence, the number of sectors is equal to the number of components. We illustrate the construction of pie diagram with the help of following example. Draw a circle of radius 5 cm. Draw radius OA at x-axis 0 degree minus horizontal. Using protractor, draw an angle of 90 degrees for football. So the sector BOA represents football. Next, we will draw another central angle 60 degree for tennis. It is represented by sector BOC. Similarly, we will draw angles for each items of the problem, and a pie chart is ready. Denote the items on corresponding sectors. We can also shade different sectors of components with different colors. Graphical representation of statistical data. Simply, a heap of data does not tell us anything. So, it needs to be processed. Processing involves arranging data in order, classification, tabulation. Such a compact or condensed form of data are easy to understand. Further, if it is graphically or diagrammatically represented, it becomes simple to understand and interpret. The specific graphs associated with frequency distribution are as follows. Number 1, histogram. Number 2, frequency polygon and frequency curve. We will study each of these graphs. Histogram. It is a series of adjacent rectangles erected on x-axis with the base as class intervals or extended class intervals if required. The height of rectangle is proportional to the corresponding class frequency. Here, the classes are required to be of same width. A typical histogram looks like as following diagram. Students, look at the diagram. Have you studied this type of diagram earlier? Yes, sir, we have studied it in 9th standard. Good. Will you tell me the difference between bar diagram and histogram? Sir, in histogram, there is no gap in between the consecutive rectangles. Yes, correct. Note that histogram is drawn only for continuous, exclusive. Procedure to draw histogram. Make class intervals continuous. If they are not continuous, we call it as extended class intervals. Take extended class intervals on x-axis. Take frequencies on y-axis. Draw rectangles on x-axis with base as extended class intervals. Take height of the rectangles proportional to corresponding frequencies. Now we take an example of non-continuous class intervals. Example of non-continuous series. To make the class continuous, we have to extend the classes equally on both the ends. First class interval should be upper limit. 500 plus 501 upon 2 is equal to 500.5. So lower limit will be 1 minus 0.5 is equal to 0.5. So the continuous class interval will be like 0.5 minus 500.5. So the new table is constructed. Scale x minus axis minus 500 is equal to 1 centimeter. Scale y minus axis minus 5 is equal to 1 centimeter. Use of histogram. Histogram is used to find mode. It is also to construct frequency polygon and frequency curve. Histogram gives idea about average where it is located. It tells us about the spread of data. It gives idea about the symmetry of frequency distribution. If two different data sets are mixed, then the histogram of such a mixture will have two peaks: frequency polygon and frequency curve. Histogram gives a rough idea about the nature of frequency distribution. The border of histogram represents the frequency distribution. The border is zigzag, so we need to make it more smooth. Using frequency polygon and frequency curve, it is possible to do so. The following figures will demonstrate how to make the border smooth. To draw frequency curve or frequency polygon, there are two methods. 1. Using histogram. 2. Without using histogram. The procedure of drawing frequency curve or polygon is explained with the help of flowchart. Prepare frequency distribution table with class marks. Draw x-axis, y-axis. Choose proper scale. Take class marks on x-axis. Take frequency f on y-axis. Plot the points xf. Plot two additional points with two additional classes. On proceeding the first class with frequency 0, the other succeeding the last class with frequency 0. Join all the successive points including the two additional extreme points by straight lines. Join all the successive points including the two additional extreme points by a smooth freehand curve. Eventually, the closed figure so obtained is frequency polygon. Eventually, the closed figure so obtained is frequency curve. Frequency polygon and frequency curve can be drawn on same graph paper together or separately by different nature of lines, such as dotted line and continuous line or thin line and thick line, or by using two different colored inks, etc. Frequency polygon and frequency curve serve the same purpose, so any of the graphs can be used. However, frequency curve being more smooth, it is preferred in use. We can draw frequency polygon and frequency curve using histogram. The procedure is as follows. Draw histogram. Mark the midpoint of upper side of each rectangle of the histogram. Take one additional rectangle of 0 height preceding the first rectangle and one more additional rectangle of height 0 succeeding the last rectangle. Mark the midpoints of these two additional rectangles. Such marks will be on x-axis, since the rectangle has height 0. Join the successive points by a straight line and get a closed figure. It is a frequency polygon. Join the successive points by a smooth freehand curve instead of straight line and get a closed figure. It is a frequency curve. Area bounded by frequency curve is equal to area bounded by frequency polygon is equal to area bounded by histogram. With the help of figure, we will easily see that the area bounded by histogram and that of by frequency curve is approximately equal. Note that area under the curve included by region ABC is nearly equal to area of region CDE. In histogram, region ABC is not included, but region CDE is included. On the other hand, region ABC is included in frequency curve and region GHI have nearly equal areas. Region EFG is included in frequency curve, whereas region GHI is included in histogram. Thus, we observe that total area bounded by histogram and that of frequency curve is nearly equal. Example marks scored by number of students in a class including all sections. Frequency polygon. X-axis 1 cm is equal to 10 marks. Y-axis 1 cm is equal to 5 students. We join the points of frequency polygon by a smooth hand-making curve and avoiding straight lines. So now we have frequency curve. Uses of frequency curve. It gives idea about mean, mode, median. It gives idea about the spread of data. It gives idea about the symmetry of the distribution.